Hello, I'm super excited to have you here. Excited to share my idea of lower limb exoskeleton design. Hi, I'm Elins. I'm a year 3 student from FKM. Let's make it short and sweet. Here I have 5 types of design to show you. Before that, please ignore the watermark. This is my first design of the lower limb exoskeletons. As you can see, there are 3 joints, which are hip, knee, and ankle. The idea I'm using in this design is there are different types of bearing in each joint. First, hip joint. Self-aligned ball bearings are used, which are insensitive to angular misalignments of the shaft and to self-align as well as operate smoothly without any stress to the bearing. Next, knee joint. Angular contact bearings are used, which it can allow for smooth spin when the knee is moving consistently. Whereas at ankle joint, gears are used, and this allows the ankle to easily modify rotary motion, and the price of gear is cheap. In this design, the hydraulic cylinders are used in the attachment between the thigh and the calf because it will provide an upward force to the user when standing up and walking. What makes my design tool special is I'm using the same bearing at the knee and ankle joint, which is angular contact bearings. This bearing can allow for a smooth spin on knee and ankles and make the movement become more easier. Other than that, in this design, 2 hydraulic cylinders are used at hip-to-knee joints and knee-to-ankle joints. This can provide more powerful upward force. As you can see, the design tree is quite simple. The size and the weight of this design is small and lighter. As usual, at hip joint, self-aligned ball bearings are used, and at knee joint, angular contact bearings are used. But at ankle joint, I'm using the self-aligned ball bearing because it has more functions and smooth. In this design 4, I'm changing the bearing at ankle joint to thrust ball bearings. Why I do this? Because this bearing can sustain axial load but not radial loads. Therefore, user can easily move their ankles up and down and easily to control the movement. This design 4 is more stable when user walking on an even surface. Okay, here is my last design. The size of this design 5 is considered big if compared to my previous design, because my idea for this design 5 is to provide low friction, high stiffness, and long service life. In order to make it happen, cylindrical lower bearings are used at the ankle joint because it can use by heavy radial loads and high speed with low frictions produced at the ankle joint. As you can see in this design 5, the waist belt is big because it can protect the user waist when using the heavy exoskeleton. The waist belt is adjustable and has soft pad inside it, therefore it is more comfortable to wear for a long period. Okay, last but not least, thanks for watching.